Hello and welcome to another video about logic. In this video I'm going to be talking to you about conditional statements, if-then statements, the kind of statement that says that if one thing is true, then some other thing must also be true. So when we say that if one thing is true, then another thing is true, the if part is called the antecedent. And the then part is called the consequent. So we're saying if the antecedent is true, then the consequent is true. And it's symbolized like this. I'm using the letter P to stand for whatever the antecedent is. I'm using Q to stand for the consequent. And then this arrow going from P and pointing to Q is the symbol for that logical relationship between them that says that if P is true, then Q is true. Notice there aren't separate symbols for the words if and then. That arrow just stands for that whole relationship. And if you wanted a single word that could stand in for that symbol, you could use the word implies. P implies Q. Although it's more natural to use the word if and then. So an example of a conditional statement would be, if something is a lemon, then it is yellow. Something is a lemon would be the antecedent, the if part. It is yellow would be the consequent, the then part. And in symbols, P would stand for something is a lemon. Q would stand for it is yellow. And the arrow there stands for that particular logical relationship between those two simple statements. That being a lemon implies being yellow. Now, unlike with conjunctions, disjunctions, with conditionals, the order matters. It matters which of the two simple statements comes first. So P implies Q is not the same thing as Q implies P. If I say, if something is a lemon, then it is yellow, that's one thing. That's pretty much true. But if I say, if something is yellow, then it is a lemon, that's not really true. Something can be yellow without being a lemon. There are other yellow things, like bananas. So it matters which is the if part and which is the then part. Some other things to keep in mind. So a conditional like this says that if P is true, then Q must also be true. Later on, we'll look at actual truth tables and truth values of conditional statements, but that's the main idea here. What this is saying is that if the antecedent is true, then the consequent must also be true. It does not imply a particular relationship between those two statements other than saying that anytime P is true, then Q is also true. So it's not saying that Q is true because P is true, that P is somehow causing Q to be true. So a statement like, if I am a chicken, then 2 plus 2 equals 4, well, that's a true statement. Even though there's no causal relationship between being a chicken and 2 plus 2 equaling 4, it is in fact the case that anytime I am a chicken is true, the equation 2 plus 2 equals 4 will also be true. And it does not say anything about what happens if the antecedent is not true. It's just saying if P is true, then Q must also be true. But if P is not true, if P is false, Q could still be true, or Q could also be false. Either way is fine. So if a cow says, if I am a chicken, then 2 plus 2 equals 4, that would be logically considered a true statement. If I'm a chicken, then 2 plus 2 equals 4. If that first part, I am a chicken, is not true, all bets are off. It doesn't matter whether the second part is true or not. Some more examples of conditional statements. If today is Wednesday, then tomorrow is Thursday. The antecedent, the thing that P stands for, would be today is Wednesday. And that might be true or it might be false, depending on when you're watching this. The consequent, the then part, the part that Q stands for, would be tomorrow is Thursday. If you live in Illinois, then you live in the United States. The antecedent, you live in Illinois. If that's true, then the consequent, you live in the United States, must also be true. Now, if you don't live in Illinois, then you might or might not live in the United States. Could be true either way. If a number ends in 0, it is an even number. You may notice I left out the word then, and you can do that. You can leave out the word then, or you can put it in. It doesn't really change the meaning or the logical relationship. So I could have said, if today is Wednesday, tomorrow is Thursday. If you live in Illinois, you live in the United States. If a number ends in 0, then it is an even number. If you eat poison, you will get sick. The picnic will be canceled if it rains. Now careful, here I put the consequent first and the antecedent second in the ordering of the words in this sentence. But the if part is if it rains. So in symbols, that's what the P stands for. It rains. And the consequent, the then part, the part that Q would stand for, is the picnic will be canceled. So the if part comes before the arrow, and the then part comes after the arrow when you translate to symbols. But in words, it could be in either order. I can say the picnic will be canceled if it rains, or I could say if it rains, the picnic will be canceled. Means the same thing. Either way, the if part is the antecedent, the then part is the consequent, and it's saying that if the antecedent is true, then the consequent is true. I'll have a hot dog if they're out of burgers. Notice which part is the if part, the antecedent, and which part is the then part, the consequent. If they're out of burgers, then I'll have a hot dog. So, in words, these two different ways of wording it, the two different orders it could be in, say the same thing. Kind of like Shakespeare wrote Hamlet means the same thing as Hamlet was written by Shakespeare. They're both expressing the same relationship between the writer, Shakespeare, and the play, Hamlet, regardless of which one I put first in the sentence. Either way, Shakespeare is the writer, and Hamlet is the thing that he wrote. And there isn't really a symbol for somebody writing something, but if there were, it might look something like this. You can symbolize it as Shakespeare, and then a symbol for somebody writing something, and then Hamlet. Now, there are different ways that conditional statements can be worded. So here are some equivalent statements. All carrots are orange. Means the same thing as if something is a carrot, then it is orange. Which means the same thing as something is orange if it is a carrot. Which means the same thing as being a carrot implies being orange. Remember, I said you could translate that arrow as implies if you want a single word that just stands in for that symbol. So being a carrot implies being orange. If something is a carrot, then that something is orange. I could also say something is a carrot only if it is orange. So only if means something different from if. It's actually going the other direction. It's a carrot only if it is orange. That's the only way it could be a carrot, is if it's orange. So if it's a carrot, then it's orange. Now, if you wanted it to go both directions, you could say if and only if. That wouldn't be true here because there are other things that are orange besides carrots. But you could say something like a number is divisible by 10 if and only if it ends in 0. I'm not really going to talk much about that right now, but I might come back to it in a later video. And if you know about sets and subsets, we could say the set of carrots is a subset of the set of orange things. So that also expresses the same logical relationship between being a carrot and being orange. Again, if you're not familiar with sets and subsets and so forth, don't worry too much about that. But if you are, that's another way of expressing that same logical relationship. Now, another thing to watch out for with conditional statements is sometimes the wording can be a little bit ambiguous, and you need to clarify exactly what you mean. Suppose I say, if you order a steak, then you can have a roll and you can have a potato. Now, what I probably mean, the most natural way of interpreting that, is that it is a conditional statement with the if part being if you order a steak, and the then part being you can have a roll and you can have a potato. In other words, the consequent is that conjunction. So if one thing is true, then another thing is true. If you order a steak, then you can have a roll and you can have a potato. But I could also mean that if you order a steak, then you can have a roll, and also no matter what, you can have a potato, whether you ordered a steak or not. That is, if you order a steak, then you can have a roll, and no matter what, you can have a potato. So if you look at it that way, the whole statement is a conjunction. It's saying that two things are true. One of those two things is the conditional. If you order a steak, then you can have a roll. And the other of those two things is the simple statement that you can have a potato. So when I translate this into symbols, I got to know what I mean, what is really going on here logically. If the whole thing is a conditional, I don't really need any parentheses because of the way the order of operations goes. It's interpreted that the whole thing is a conditional and the and part comes before the implies part. But if I mean for the whole thing to be a conjunction and one part of that conjunction to be the conditional if S then R, then I do need parentheses around that part of it. And it does change the meaning. Let's practice translating from words to symbols. In this example, C will stand for the simple statement, it is cold. R will stand for it is raining, and P will stand for we will have a picnic. So how would you write, if it is raining, then it is cold? Well, that would be if R, then C. So R, and then the symbol for a conditional, and then C. R implies C. What about if it's cold or it's raining, we will not have a picnic? How would you write that in symbols? If C or R, then not P. How about we will have a picnic if it's not raining? Notice what the if part is. You have to write that first when you write it in symbols. So if it's not raining, then we will have a picnic. Now let's try some the other way. In this example, J stands for Joe will go, R stands for Ray will stay, and S stands for Steve will leave. If Joe will not go, then Ray will stay. It is not the case that if Joe will go, then Ray will stay. Joe will go, and if Joe will go and Steve will leave, then Ray will not stay. Joe will go, and if Ray will stay, then Steve will leave.